Okay, so last ones look complicated, but they aren't, and I think I've got some stuff that'll help you on it. And it's like 3:30 in the morning, so hopefully some of this makes sense. Okay, so a particle moves in a circle in such a way, notice they said circle, in such a way that the x and y coordinates of its motion are given in meters as functions of time. In seconds are, so this is actually like, I'm going to change that, that is x as a function of t, y as a function of t. I'm just scratching that out. Okay, and notice the 5 is the same on both. I'm going to get into that in just a second. All right, first of all, the equation on your equation sheet says this, and this is awful. It says that. That's not useful. Let me fix it for you. Okay, x as a function of t equals x max. Think about that. What does that mean? That means your highest point or your amplitude, sometimes useful. Okay, cosine, and this is angular frequency, it's like angular speed, times your time interval, not your time period, the time you actually choose to measure with a stopwatch. Okay, I've never seen them use this. I'm praying there's a first time for everything, but this is called a phase angle. So this means instead of starting at like your highest point or at your equilibrium, and if you're using cosine, you would be starting at your highest point or your lowest point, basically, that it's going to be slightly off kilter. It's going to be like starting in the middle, like if this is your cosine kind of thing, it would be starting like right here, okay, to where like you just move your axis over right here, and it's like some kind of strange thing. It's called phase angle. Like I said, I have not seen them use it. I think they just mess with you, but there's a first time for everything. So just that means it's kind of off a little bit, and you can figure that out, hopefully, if you need to. But this is the useful equation. Okay, so another way, well, I'm not going to get into all that right now. Okay, so you have this. So this moves in a circle. So how can these two things move in a circle? Glad you ask. I'm so proud of this. Let's see if I can actually get it to play. Yay! See, if you notice, this is moving in a circle. Ignore the spirally pattern it's making. It's actually moving in a circle. So hopefully that helps out some. Anyway, so let me work this problem out for you. Okay, so what is the radius of the circle? Well, actually, why did I erase that? Well, let's look at this. If I just space this, go a little bit. Okay, wait, let's look. See, right there, that's where your arrow is longest. Let's just say that that is, for our purposes, that longest arrow thing was 5 meters. I don't know if this will let me play this. Okay. So wait, let me see if I can get it to the highest point, or to the longest point on the, I'm thinking that is the, whoops. Let me get back to that. Sorry. I'm thinking that's the longest point from this frame of reference on your Y. Whoops. On your Y. But anyway, it's going to be 5 meters that way too. Basically, this is your radius. And that's your amplitude. That's like what creates your highest points here and your lowest point here. So that's your amplitude. So 5 is the radius of your circle. So the answer is C. Now, which is true of the speed of the particle? Now, you're going to want to look at two things on this. Your speed, that would be like your linear speed, right? Think about how that relates to this. Remember, that is just, speed is just your angular frequency, which is like your angular speed, times radius. So that would be 3, so that's the same on both of them, times 5. So that would be B, 15 meters per second. I think that's all of them.